All right, bet I'm gonna put this down. Is that okay, Chloe? Okay. Actually, I might block my nose actually if I leave it right here. Okay. All right. No, it's impossible. The nose is too big. If you look at the bottom of that homework, I gave you all the payouts and the odds for this game of Powerball, or whatever the hell it was. I forget if it was Powerball or if it was Mega Millions, which is essentially Powerball, but it's a different branding of the game. The game that the people won is called Wheel of Fortune. That's the one the person won almost $1 million on. This thing that's right down here, you don't have to know this. This is called a PAR sheet, P-A-R sheet. Every game of chance in the state of Oregon legally has to have one of these publicly available. So you have to know how likely it is that you're going to win the prizes. The only game I can't find a PAR sheet on is the Wheel of Fortune game that person won $1 million on. All I have data-wise from that game, because I've never actually seen it. I've never seen one in a casino. The only data I have is people going, never play that damn thing. I blew $30 in 5 seconds. Holy shit. Because apparently you have to pay in so much to play it, and it very rarely pays out anything. Not even just like minor prizes like this one does. Because you're right, this one pays out a lot of different prizes, right? It pays out, you can win $1 million. You can win $2, which is basically a free ticket. Yeah, you can win a ticket back. You can win $4. You can win $10. I mean, there's a whole bunch of little minor payouts. The Wheel of Fortune pays back one thing, the jackpot, and that's it. Somehow it's popular with people. I don't understand why it's popular, but it is. What you got, Dre? Have you seen it?
Yeah, I've seen it.
You've seen the Wheel of Fortune game.
Well, I was going to ask, I hope it doesn't throw everybody off, but like, how much do they lose, and then obviously the tax from the...
This is a very, very good question. I'm going to leave taxes out of it. Only because I want to focus on just the likelihood math, the probability of winning each prize. The taxes have nothing to do with that. That's just the way the government going, wait a minute. We need more money to pay for our oak desks and our big fancy leather chairs. What else can we tax? Oh, that dead guy over there, let's tax him. And let's tax all these lottery winners. So we're going to leave taxes off just because it's extra math that doesn't help understand this math.
Yeah, that makes sense.
I love it. I love it. Thank you, sir. Elle, go ahead. The yellow dots, all they are is the Powerball, so to speak. So the way Mega Millions works is you have to get a certain... Have you ever seen Powerball? The game Powerball? So I'm going to use Powerball because I know it more than Mega Millions. So Mega Millions is a more localized game. There's like 1 to 35 ping pong balls that are numbered, 1, 2, 3, 4, in a big tumbler. And then there's a second tumbler full of yellow balls that are numbered like 1 to 40 or something like that. And what they do is they circle the balls and they pull 5 of them out. Those are the 5 normal balls. And they go, and they put those in a row. And then they go pull the Powerball, the extra yellow ball. So all that yellow ball means is you got that number correct in that arrangement. Is that right? So when you see 5 plus 1, the 5 white balls plus the yellow ball, that means your ticket has all 6 correct numbers on it. Which only happens one out of, well, we'll get to that in the back. It's on the back side. The yellow thing is an extra ball. Just think of it as a 6th ball. Don't even worry about it. The colored balls are not part of this class at all. All you got to know is the payouts and how likely it is that you get that arrangement. So don't sweat too much about the yellow versus the... At break, I'll see if I can't find a video of one of the draws so you can see the drawing of it, and that will make a little more sense, but it's not important for this. Everything you need is on the homework already. Okay? All right. Let's go through this together, if I may. Okay, so the whole biz, blah, 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 blah. Okay, so the first thing I asked you to do in number one, I asked you to do the expected value, the average, the same way that we just did on these games. Which means add up all the winnings and divide by how many winnings there are. Let's do that first, yes? Let's do that first. Okay. So somebody give me all the winnings. You can read them off the first page. Off the first page, they're all listed.
2, 4, 10, 10.
Hang on one second, make sure I can see it. Okay, we see this, okay. Okay, so I heard $2 first, is that correct, Jenna?
Yes. 2, 4, 10, 10, 200, 500, 10,000.
Oh God, slow down. Was there a 200 or a 100?
200.
200. What was the next one?
500.
500, got it.
10,000.
10,000.
And then 1 million, I think.
And then a million.
And then jackpot.
And there's a jackpot. How much was the jackpot? I put it on the homework somewhere.
118.
18 million. So there's the one. I think I got enough zeros there for the
118.
100. Oh shit, 118 million. That's awesome.
No.
118 million? There we go. Let's make sure I got enough zeros here at all these. So
Oh, I
118
see.
million jackpot. A million, which is the next, that's the prize if you don't get the Powerball, right? That's just the 5 non-Powerball balls. 10,000 bucks, which is something. Maybe it's 4 and 1, I think.
Plus the, yeah.
4 and 1. 500, which I'm guessing is 4 without 1. 200, which is 3 and 1. I think I'm gonna try to guess now.
Yeah.
This is 3 with no 3 with a Powerball. 3 without the Powerball. 2? No?
Yeah.
2 and a Powerball. 2 and a Powerball. Sorry, 2 and a Powerball. Just 2? 1 in the Powerball. Powerball by itself. Oh, so you. Oh shit. So if you only get 2 of the non-Powerball numbers and no Powerball, it's a loss. Okay, good. Okay, let's file that away for later. Thank you. We'll file that away for later. Okay, people. How many prizes do you see?
There's 9.
You know what to do. Add them up, divide by 9. And then divide by 9?
Yeah.
Yes. Let's do it. I'm going to do it on the screen too. This is damn good. Let's do it worried.
It'd be nice if I won that.
No, it would be, wouldn't it? Well, you don't win it, you average it.
Still be nice.
All right. Let's do this together. Okay, so we got 118 million plus a million plus 10,000. Check my math on this. Plus 500, thank you. 200, thank you. 2 tens,
4
a 4,
and 2.
and a 2. Okay, I got 119 million, $10,726.
Yeah.
Divide that by
9.
9. Watch this order of operations magnificence. Put that whole thing in parentheses. Okay, there we go. What is
Yep.
that?
So I got about
13,223,000.
So that's the answer to number 1. Yes, 13,223,000.
That's money.
Why are we playing this game? Remember what that means. That is the average we are going to win if we play this game. Now, the question number 2, of course, is the most important question of the first 2. Give me at least one reason why that can't be true, Alexis.
I said because you can't just assume you're going to win every game.
But we just mathematically proved it. But we didn't.
But we didn't.
But we didn't. So what did we, Jared, what are you thinking?
There's a lot of different options you can end up with as opposed to 6 in a dice game.
Keep that right here. Listen to what Jared just said. There's a lot of different options besides just the 6 in the dice game. Okay, that's part of it. What else is part of it? That's huge that you just said. What else is part of it? Jenna, go ahead.
so I said because you won't always win or have a positive amount.
But we just proved you do. That's the average. That's the same average we did with the dice game, right?
But there's no.
Because you don't always win that amount.
But we didn't always do that with the dice game either.
Isn't it?
We got the average, right?
Yeah, yeah,
Yeah, Alexis, this is good though. Keep pushing back, Toby.
Just the average out of 9 games, the margin of error is too small.
Why is dividing by 9 wrong in this case, but dividing by 6 was right in the other case? Nikki, what are you thinking?
Because it doesn't account for the losses.
Okay, there's one big thing we forgot. There's one big thing that we forgot. We forgot they gave you the par sheet, which is all the ways you can win. There's also one other win in this game, and that's losing. But, check this, if I may. We can fix that really quickly. You ready for this? Do you know how much one of these tickets costs?
$2.
$2. So all we've got to do to account for that is at the end of this addition, let's just put a plus negative $2 on. There we go. And then add those up and divide by 10 instead of 9. Here I go. Plus negative 2. And then divide by 10. There we go. So now we are only going to rock in 11.9 million instead of 13 whatever million. Sign me up. when we divided by 6, turn this off for a second. Turn this off. When we divided by 6 with the dice game, what was that 6 assuming about all of the outcomes of the game?
That we would get something.
No, sometimes you lost something, right? Sometimes they were negative. What was it dividing by 6 doing, Macy? What was it assuming?
Make it all positive.
Every number, one more adjective on the end of that. Every number rolls.
6 times.
I'll give you a hint. Every number rolls 1/6 of the time, which means every number falls equally. So you could divide the total up into 6 equal pieces, because 1/6 of the pieces are going to be 1s, and 1/6 of the pieces are going to be 2s, and 1/6 are going to be 3s, and so forth. Let's consider this lottery game. If that were true for this lottery game, that would mean the same number of people would be winning the jackpot that are losing $2. In other words, winning nothing. And the same number of people would be winning the jackpot as would just win $2. And the same number of people, in other words, 10% of people out there that play this game are winning the jackpot every time. 10%. That's what divided by 10 means, right? That's 10%.
So it's not evenly
Say it again.
it's not evenly distributed.
Say it one more time.
It's not evenly distributed.
Not evenly distributed probabilities. Everybody, take the. Oh, you're already on the backside, aren't you? Yes, you are. You're already on the backside. Look at the chart. Right, hold that thought line. I'm going to get you, I promise. Look at the chart on the backside. It's the same as the chart on the front side, except what is next to the payouts for the prizes?
Odds.
The odds of the things actually happening, which tells us that none of these things happens 10% of the time. Not a damn thing happens 10% of the time. As a matter of fact, how often does the jackpot happen? The jackpot happens 1 every 302 million tickets. There's a slight difference between 1 out of 302 million and 1 out of 10. Oh God. Does this make sense? Alexis, you buying this?
So sorry. So
No, go, please.
so
Don't be
it's gonna
sorry. This is
dis-
awesome.
Because like the probability isn't.
Yes! Yes, you just said. You used the best words. You said they're not uniformly distributed. These are uniformly distributed, these dice games.
Okay.
And the reason they've been working in our labs is because everything was based on a single roll of a die, which is uniformly distributed. Guess what's not? Pretty much everything else in the world besides a 6-sided die. So what we have to do is, this is where the divided by 10, divided by 6, divided by 9 thing won't work. This is why. Now, Alexis, I remember you asking this last Tuesday. It was a great question. You asked me after we got done the experiment in the lab, you said, why didn't you just let us do it this way, divided by 6, rather than collecting all that data? It's a fantastic question. And you remember what I said? I said, give me a week, we'll come back to it. And here we are, my awesome friend. The reason why is that only works if the experiment has the same possibility for every outcome. Most of the time, you don't. I use this as a hilarious example. What is the chance I'm going to get hit by a car when I go through that crosswalk later?
50.
Well, I either do or I don't, right? Does that mean it's 50-50?
No.
Sweet Jesus, no! Because if it was 50-50, I'd be dead multiple times over by now. There's 2 outcomes, but they're not equal outcomes. It's not flipping a coin. Thank Jesus. Thank Jesus it's not flipping a coin. That would bode not well for me.
It would be like flipping a coin, but then rolling like a.
I like that answer, Simon. It would be like flipping a coin and then rolling, or flipping a very special coin that maybe has 100,000 sides. We'll call it a 100,000-sided die. And there's one little black dot on one of the sides. And that's the Sean is dead dot. And every time I go up to that crosswalk, I throw the die. Okay, cool, go on.
Because the coin would represent like a car coming. and-
Or me getting hit by the car.
Well, no, like if we're talking in terms of like a little dot on it.
That would be me dying or not in the crosswalk.
So 50-50 if the car is.
What's this 50-50? Stop with the 50-50. It's never 50-50.
Because
Stop with the 50-50.
no, because I'm also trying to relate it to this.
I got it. Let's relate it to this right now. Can we do it right now? So what we have to do is, we can't add up all these and divide by 10, because that makes the assumption they're all equally distributed. What we have to do is we have to run the math on each outcome, each prize, and its probability. So let's do it. Let's do it. Let's get it. All this is going to go away. Oh yeah, we're going to do this. This is number 3 now. We're going down to number 3. This is number 3. Yes, Alexis. And then we're going to see what number 4. I don't know what number 4 is, but we'll get to it. Okay. So where do you want to start? Do you want to start with the big prize and work down like the par sheet does?
Yeah.
With the jackpot and work our way down? I'm down with that. So the jackpot was $118 million, yeah? Okay. But how often does a jackpot happen? 1 in?
302, 5.
575.
Okay, so somebody just give it to me. 302.
575.
575.
350.
What 50?
3.
Thank you. That means there are that many tickets that are possible to be sold with this game of Mega Millions. And only one of them is the jackpot. Has anybody ever heard the strategy for a game like this? Just go out and buy all the tickets. You ever heard that strategy? Yeah, of course. Go out and buy all the tickets. That way you know you have the jackpot winner. The problem is there are 302 million tickets that each cost $2. That's $600 million you've invested, and the jackpot's only a fraction of that. Trust me, they've thought of that. Not to mention the fact, you know how hard it would be to buy all the tickets? Go to the store and be like, okay, here I go. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 3. 1, 2, 3, 4, 5, 4. Somebody stop me. 1, 2, 3, 4, 5, 5.
Stop.
Thank you, Jesus, people. 7 weeks. Stop me when I start doing crap like that. Nikki. That's along the same lines as what Dre said about taxes. If somebody splits the prize with you, it cuts your jackpot down. Yes, there's all kinds of things mathematically that are working against you from making money at this game. You're about to see how much you make each game. Go ahead, Simon, and then Larry, I get your point too. You had a point earlier. I want to make sure I get to you. Go ahead.
Mine's more like a hypothetical question. I'll wait after.
Okay, good. Larry, what was you were going to say earlier? I had you pause for a second.
The way I figured it though is 23 out of 24 tickets that don't win.
Lose. We're going to get to that. Down at the bottom, I promise.
Which is 95% are losing.
Can we come back to that? Give me like 5 minutes till we get to the bottom of this calculation. That's going to be at the very end. Okay, the next one I think was $1 million, right? Yeah. That was $1 million, yeah? So I'm going to stack them. Kind of stack them vertically for the most part because it's going to be kind of hard to see this side by side. Okay, so we're going to add $1 million. But what's the chance of winning $1 million, my awesome friends? 1 in. Just give me the digits.
12, 607, 306.
Okay, so yeah, you can win $1 million, but there's 12,000 tickets.
12 million.
12 million tickets. I'm off by it. Yeah, 12,000. So the problem is, anyway, you're seeing the problem now. Now that we're adjusting for how hard it is to win the big prizes, you're beginning to see how often, or in this case, how rarely the big prizes get hit. Next up, I think, is 10,000, yes? If I remember correctly. Okay, good. How many tickets? 1 in? Give me the digits for this one. 1 in? 90,000?
931
Oh, 931?
001.
Oh, look at that fun one. Now you have to realize, I want you to realize something, my friends. This is still the total number of tickets. What they've done down here is they've made a denominator so that 1 can be the numerator. So there's still this many tickets out there. There's just more of $1 million tickets than the other ones. And don't worry about that. Just all you need is probabilities. Okay, good. Next up, $500. Is that correct? Is that the next prize? $500? Okay, thank you. 38,792. Getting there. Next prize, 200 is the next prize, if I remember correctly?
Yes.
200. I'm going to stack it over to the next side. Is that okay? This is going to be a big ass math expression. Plus 200 times 1 in.
14,547.
Okay. I think the next was 100.
10.
I said 10. 10 times 1 in. 606. Notice how this number is always bigger than that number. They know that. Always. And as a matter of fact, if you want to think about it in terms of profit, you'd have to double this because the tickets are $2 a piece. So you'd have to spend $1,200 to maybe win 10. You see how that's a losing proposition? Okay, good. They know this. They know this. That's how the game works.
But didn't-
Okay, let's keep going. Next one's 5. No, next one's 10.
Oh, yeah.
It's 10 again. Okay.
And the one in 693.
Those bastards, they went back up. Sons of bitches. Now it's 4.
Yep. One in 89.
Ah. Oh, yeah. And then it's 2.
Yep.
This is winning a free ticket, essentially. Should I, everybody back there, should I move to the top corner to make it easier to see? Maybe I'll pump it up again. McKenna, I'll bump it up to the top corner. It's getting hard to see behind those things. Okay, good. I think, yep, we can still see it here. So this is one big ass math expression, sorry. We're almost done though. We have this one and one more. What's the one more? Plus 2, win the free
1
ticket.
in 37.
1 in 37. Now I'm going to stop you right here for a second. If this were the entire expression, if we were done, if we could figure out what this equals, and we were done, I would propose that we all leave this room and find the nearest, where do you buy these tickets? Gas stations. Chevron, right down the street. Let's all go to Chevron and buy a bunch of tickets, because I don't even know what this number is, but I know what kind of number it is. What kind of number is this going to be when it's done? Say it again! Sorry, Simon. It's going to be a positive number, which means on average, we're going to be winning money. But we're not done, are we? Because isn't there one more prize? What's the last prize? Richard? Thank you, sir. Times whatever, I gave it to you. I think it's 23 out of 24, and this is what Larry figured out. Over. You read the fine print, and I made it not so fine. I put it in big, bold-ass fractions down there. I said, there's also one more you need to know. There's a 23 out of 24 chance that you don't win anything, which means that you win -2, which is a loss of 2. And Larry was kind enough to figure out what that probability was. If you divide 23 by 24, it's about 95%, 96%, yeah? That means of all tickets sold to this game, 96% don't win a thing. All of those fractions right here add up to about 4% or less. So if you buy 100 tickets, maybe 4 of them win. Maybe, if you're lucky and you hit the average, 4 of them win. And the ones you're winning are probably those little tiny amounts down there. So here's how we wait for the loss. When I say wait, I mean W-E-I-G-H-T, not like wait, like W-A-I-T. We're going to weight it with the 23 out of 24. Here we go, one more. Plus -$2 times 23 out of 24 tickets. So if you buy 24 tickets, 23 of them are going to lose. And the one might win. And it's probably going to win a really small amount. Let's take our time right now and do that. That is a hell of an expression, but guess who's ready for it? Let me see hands in the air. Thank you, Claire. That rhymed with hands in the air. Claire. You all are. This is an order of operations nightmare, except you're all ready for it, aren't you? Do it. Take some time right now. Do it.
So wait, we're adding.
You're doing the multiplications, then the additions. Order of operations, right? Multiply, then add. So multiply, piece, 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 all the way. I'm going to do it in Google. Is that okay? And then we'll compare answers when we're done. I won't turn it on yet. You just gave me a really good idea, all of you. Thank you for this. I'm going to build a Powerball simulator for next class in Excel, where we actually have the tickets run. Oh, it's going to be fun, I think. Maybe it sucks. I don't know, Rebecca. It might be good. I think it might be kind of cool. Yeah, see the Powerballs going by and then see if we match the, oh yeah, okay. I like this. That's going to be, I'm sorry that I didn't think of that before right now. That'd have been fun to have in class. Oh well. Fortunately, I have all the prizes in here already, so I can do one. I'm going to stop talking. Crazy ass is right.
Yeah, cool.
I agree. Crazy ass. Let's talk about something else. This is This is a fairly crazy ass right here. Ooh, that's an ampersand. I don't need that. That's a fun word we don't use enough. Ampersand. Is what's that?
I wasn't and then I started it.
Oh shit! Well, you know what's easy to do, Ginny? It's very easy when you're doing this math to get lost in the math. Because there's so many fractions going on. So what I'm doing, my awesome friend, is I'm just doing it all in one big, I'll show you in a second. I'm just doing it in one big Google window, all simultaneously. That way I can match up the prize with the fraction. Yeah, if anybody's using their cell phone to do this math, I give you credit. I can't do that.
Well, my phone keeps going
Well, and that's because, here's the thing. The reason is,
decimals.
the millions are being turned into scientific notation. I'm going to show you what I'm doing up here. I'll just give you a quick peek. I'm just putting it all like up in the search bar at once. I'm going to press enter at the end, and then I can do two things. I can check the answer, and if I screwed up, which is likely, I can go back and figure out where I screwed up pretty easily. Does that make sense? Yeah. Let me finish her up, and then I'll share it with you. The 10 is 1,693. Okay, times that 10. Alexis, I'll never forget that question you asked last Tuesday. It's okay if you did. I did not, because it was fabulous. And that's where this warm-up came from, or that's where this homework kind of came from. 1 in 89. Alexis is like, thanks, with my mouth shut from now on. Times 1 in 37. And then last but not least, the negative 2. 23 out of 24. Oh, there it is. And then I don't have to divide by 10 anymore, because we already took care of the division by everything, because the fractions are there. Do you want to see what I got up on my calculator?
Yeah.
I didn't check it yet. We'll have to check it against yours. Is it okay to pull this down over the? Is it okay?
Yes.
Mace, it's okay. Okay, good. Okay, here I go. Again on my own. I got negative $1.28.
No, I got something completely different.
Did you get a negative number?
No.
Then you did it wrong. I'm not to be crass. The number has to be negative. Why?
Because there is a negative, you get a negative outcome with the -2.
And more globally, I love that answer, by the way, Alexis. But how can, Alexis, may I push?
Yeah.
How can it be a negative answer if only one of the 10 prizes is negative?
Because we're using multiplication,
Uh-huh.
and there's no other negative to cancel out the other negative.
That's
multiplication.
true, but there's so many positives. Why don't the positives cancel the negative?
Because the negative is attached
To the largest fraction,
Yeah.
23 out of 24. As Gabe said, all those positive fractions are teeny tiny. All those positive fractions add up only to 4%. Let's check my math and make sure I did it right. Let's go through my math, okay? Let's take a look. I've got 1 divided by 302,575,350 times the $118 million jackpot. Is that right so far? Is that right so far, awesome people?
Yeah.
Okay, good. Then I added to that 1 in 12,607,306. I multiplied that by 1,000,000. Is that right so far? Good so far? Okay, good. Then I did 1 over 93100.